this is Algebra 2, Lesson 11. We're going to talk about the addition of angles and inscribed angles. We're starting on page 62. The addition of fractions, also known as common denominators, are back. Woohoo! To add fractions whose denominators are equal, we add the numerators algebraically and record their sum over a common denominator. So we have 1/11 plus 5/11 minus 4/11. So we would say 1 plus 5 minus 4 over 11. And this is 1 plus 1, so this is 2/11. Here we have a over b plus 2 over b plus a plus 3 over b. So we can say a plus 2 plus a plus 3 over b, which is 2a plus 5 over b. Right? When the denominators are not equal, one or more of the fractions must be changed so that the denominators will be equal. So we have 1/2 plus 3/4. We can't add them together right now because the denominators are different. So we find the least common multiple. In this case, the least common multiple would be 4. This side is already 4. We can't change the value of the either fraction, so we have to actually multiply times 1 so that the value doesn't change. In this case, we're going to multiply this by 1 by multiplying it times 2 over 2, because 2 divided by 2 is 1. We're not changing the value of this fraction, we're just changing the form. So 2 times 1 is 2, 2 times 2 is 4, and now we have 2/4 plus 3/4, which we can add. Okay, let's look at this one. We have a over b plus c over x plus d plus e over 4. The lowest common multiple is going to be 4bx. Okay? In order to get this one to have 4bx in the denominator, we're going to multiply it by 4x over 4x. Remember, the value of 4x over 4x is 1, so we are not changing the value of this term. We're just changing the form. This one's going to have to be multiplied by 4b. And this one's going to have to be multiplied by bx. Okay? Now we can multiply these through. We'll have 4ax plus 4bc. I'm changing these into alphabetical order. You don't have to do that. Okay? It's just neater. So I do it, but you don't have to do it. Alright, this one's a little trickier. bx times d plus e. And these are all over 4bx. If you are in my class, I do not want you to leave parentheses in your answers, unless parentheses are what we were looking for. If we are simplifying and solving things in my class, please take the parentheses out. I know your book leaves them in. For my class, take them out. So we're going to distribute this. So we will have 4ax plus 4bc plus bdx plus bex over 4bx. Okay? I want you to do this because as we get to more complicated expressions and equations, sometimes the things in the parentheses are going to end up with like terms. So pull all the parentheses out so you can look one more time for like terms. And then the final answer will not have any parentheses in it. Okay. The denominator-numerator rule. A over b equals ac over bc because c over c equals 1. B and c cannot equal 0. So here's the rule that goes with what we do with fractions. Okay, here's an example. We're going to add k over 2a plus bc over ax squared minus m over ax cubed. So the least common multiple of these denominators is going to be 2ax cubed. Okay? So we have k over 2a plus bc over ax squared minus m over ax cubed. I'm rewriting them because I didn't leave enough space on the top. Alright, this one we need to multiply times x cubed. So x cubed over x cubed. This one we're going to multiply times 2, and we need another x. So this is going to be 2x over 2x. This one, we've already got the ax cubed, so we just need the 2. So 2 over 2. Okay? Multiply that through, and we will have kx cubed over, oh, they're all going to be over 2ax cubed. So plus 2bcx minus, don't lose that minus, 2m. Okay? And that's our final answer. There are no like terms there, so there's nothing we can do to simplify. Okay, let's try the next one. Add m over k minus b plus cx over ak squared. So our least common multiple for the denominators is going to be ak squared. So we have m over k minus b plus cx over ak squared. Alright, this one's going to need an a and another k. So ak over ak. This one doesn't have a denominator. Well, it's 1. So we're going to multiply it times ak squared over ak squared. And this one's already there, so we don't need to do anything to that. So we have akm minus abk squared plus cx over ak squared. Okay? Okay, back to geometry. Inscribed angles. We remember that the measure of an arc of a circle is the same as the measure of the central angle whose radii intercept the arc. So, here is a circle. Here is the center of the circle. Here is the sector of the circle that comes from these two radii coming from the center. This angle is 44 degrees. So the measure of this arc from here to here is also 44 degrees. Right? An angle whose sides are inside the circle and whose vertex is on the circle is called an inscribed angle. So if instead of the vertex of the sector being in the center of the circle, now the vertex of the angle is on the edge of the circle. It's on the line that makes up the circle. Okay? This is called an inscribed angle. The measure of an inscribed angle equals half the measure of the intercepted arc. The intercepted arc is right here and right here. So this is the arc, actually right here, that has been intercepted by this angle. And the measure of this arc is going to be 2 times the inside angle here. So it's 44 degrees. So you can say, depending on what you're given, if you're given the measure of the arc as 44 degrees, you know this angle is 22. If you're given this angle is 22, then this arc has to be 44. Any inscribed angle that intercepts a 44 degree arc will have a measure of 22 degrees. So here's a 44-degree arc, and here are 3 angles that inscribe it. They're at slightly different angles from this point. Their slopes, the line slopes to get to the end of the circle are different, but they're still inscribing the same arc, so their angles are the same. Okay? The endpoints of a diameter intercept an arc whose measure is 180 degrees. So here's the diameter of the circle. If we consider this a straight angle, then the arc it's intercepting is this whole thing, which is half the circle, which of course is 180 degrees. This is also an arc that it's intercepting, and it's also 180 degrees. Okay? Any inscribed angle that intercepts a diameter is a 90-degree angle. So here's an angle, and it's right here at both endpoints of the diameter. So this angle has to be a right angle. It has to be 90 degrees. Here's another one that is intercepting the diagonal, so it has to be 90 degrees. And here's another one that's intercepting the diagonal, so this has to be 90 degrees. Okay, if we had drawn one down here, from here, and this went this way, and this went this way, and assuming these were straight lines, which they're not because I'm freehand drawing them, any inscribed angle which bisects the diameter, this is going to be a 90-degree angle. Okay? Okay. So here's an example you're going to see a lot. Here is an inscribed angle. We're going to look at the big black angle right now. Okay? One of the legs of this inscribed angle passes through the origin. Here's the origin right here. So it's the diameter of a circle. So this line from B to C is the diameter of the circle. If the measurement of AC, arc AC, so that's this arc right here, if the measurement of AC, this is how you say arc, is 80 degrees, if this is 80 degrees, then we know this is 40 degrees because this is the inscribed angle, and it's going to be half of the measurement of the arc. If we draw a line from A to O, okay, so that's this point on the edge to O, and O is the origin. Remember, it's the center point of the circle. This is now a radius. Okay? And this angle that's been formed is going to be 80 degrees because now we have a circle, a sector of the circle formed by 2 radii. And so it's going to equal the measurement of the arc. Okay? We can see that, let me get another color. If this is 80 degrees, we can see that this angle is actually supplemental to this one. So AOB is supplemental to AOC. So this is going to be 180 minus 80. So this is actually a 100-degree angle. Can't really tell that in my drawing, but it is. Okay? Okay, so these are the points to remember. The measurement of an angle formed by 2 radii and going to the origin, the measure of the angle is going to be the same as the measure of the intercepted arc. If the vertex of the sector meets on the outside of the circle, then the measure of the intercepted arc is going to be twice the measure of this angle, of the inscribed angle. So if this is 22, this is 44. If it's a diameter, then it's making 180-degree arcs. if the inscribed angle meets at either side of the diameter, then this is always a 90-degree angle, which means that its intercepted arc is the other half of the circle. So this is actually a 180-degree arc and a 90-degree angle. So it's still twice as much. That just makes sense. Okay? So this is 90 degrees. This is 180 degrees from here to here. Okay? We can use that if we have a line passing through the diameter, and then we put a line here. Now this line is from the radius. So this angle is going to be twice this angle. It's going to be the same as this angle. And then this angle is going to be supplementary to this one. If you know 40 and 100, you can find this one. 100 plus 40 is 140. So this one is also a 40-degree angle. Right? Okay, these are the things you're going to need to look for as you're doing your homework. Let's try an example. We're going to find x. We have an inscribed angle of 40 degrees. The arc from here to here is 5x degrees. The arc from here to here is 7x plus 40 degrees. This is actually the inscribed arc from this angle. So if this is 40 degrees and the vertex of the angle is resting on the side, then this is going to be twice this. So this is actually going to be 80 degrees. So now we have the measurement of the arc from here to here, the arc from here to here, and the arc from here to here. And we know that the distance all the way around the circle is 360 degrees. So we can add 80 degrees plus 5x degrees plus 7x plus 40 degrees, and it has to equal 360 degrees. And we should be able to set that up and then solve for x. So we have 80 plus 5x plus 7x plus 40 equals 360 degrees. Let's simplify this. We have 12x plus 120 equals 360 minus 120, and 12x equals 240 divided by 12, and x equals 20. Okay? Try your practice problems, do your homework, let me know if you have any questions, and get rid of parentheses. Thank you.